Welcome to the CAD Office Training Guide series for FDOT Connect for OpenBridge Modeler. My name is Joel Gutierrez, and I am a structural engineer at WSP USA. In this video, we will be covering exercise 7.1 from the Bridge Design 3D and Plans course guide. This exercise demonstrates how to generate various native data reports from OpenBridge Modeler. Let's get started. So to begin this exercise, I'll start with a brief discussion on some of the background information regarding the reports. After that, we will begin working step by step through the generation of the first report in this exercise, which is the bridge quantity report. This will be the native report that has the default OpenBridge Modeler formatting. The process for generating the FDOT formatted quantities is demonstrated in a later exercise. Next will be the generation of a deck elevation report. This provides the top of deck elevations, or in FDOT terms, finished grade elevations at specified locations. Next, we'll use the civil data to generate a geometry report, showing all roadway information associated with the bridge alignment. And the last report that will be generated is the input report that simply lists all information that the user has input into the model. So the creation of these reports can be very beneficial to an OpenBridge Modeler user. Uh, it really allows the user to take advantage of the model-centric bridge workflow when looking to generate FDOT deliverables. It can also be very beneficial in the quality control process. So for instance, if you generated your own calculations for elevations or for quantities, um, using these internal reports from the program can allow you to have some kind of sanity check up against your numbers. So now I want to dig into some of the limitations of the program. So as a designer, it's important to understand all the limitations to these reports and know that ultimately you are responsible for verifying the accuracy of the reports generated from the program. It's also important to remember that the quality of any of the output is fully dependent on the accuracy of the input into the model. Everything is only going to be correct if the user correctly inputs model data. So for instance, when we're talking about the quantity reports, the appropriate feature definitions, templates, material types, and numerical inputs all need to be correct when initially creating the model. This will allow you to create a more accurate quantity report. One of the things that the user also needs to be aware of is things that are not modeled are not going to be included in the quantities. So one good example of this is the FDOT workflow currently does not model thicken end slabs. So in the deck concrete quantity, those thicken end slabs will not be accounted for. Another thing to be aware of is any kind of unique geometry that requires some kind of workaround may cause information that's in the input report to not exactly reflect what's shown in the model. An example of this in the FDOT workflow is how we use solids modifications to edit the ends of skewed end vents. Because those changes are made using solids modification, that will not be reflected in the input report. So now we're going to get started working step by step through exercise 7.1 with our 7.1 underscore begin DGN open. Currently you can see that the working units are set to feet, inches, with fractions of an inch also being reported. Because we don't want any fractions of a cubic yard or anything like that shown in our quantity report, we're going to update that to reflect what the FDOT basis of estimates would show. So here we're going to go up into the File tab. We're going to go over to Settings. You'll click on File and then Design File Settings. Next, you'll have this pop-up window show up. You'll need to make sure you click on the working units down here in the category, and then we can start changing our linear units. So the first thing we'll need to do is change from master units colon subunits to be master units only. We're going to keep the master unit as survey feet and then change the accuracy to be 3 decimal places. Once you have that all reflected, then we can go ahead and click OK. And then we can go click back. One thing to note is if you want that to stick, when you close the file and reopen it, you'll need to make sure that you click Save Settings. So I'll just go ahead and do that now. The next thing I want to quickly discuss before going into the actual quantity report is to notice that you can select what bridge or unit you have active over in the Explorer using the Explorer window. For this model here, we only have one bridge and one unit modeled. However, if you were to have multiple bridges or multiple units modeled in a model, you can go into this window and set what you have active in here. And that's denoted by the icon turning green on each individual category there. So that's going to be useful information in a second. The next thing we're going to do is open up our actual quantities report preview window. So I'm going to go up into the Reports and Drawings tab, go into the Bridge Reporting group, and click on Quantities. So as I mentioned a second ago, you can choose which bridge or unit you have active. That's important because whatever you do have active is going to be isolated in the report. Now, if you do want all bridges or all units shown in the quantity report, all you have to do is set it to all over here. For us, it doesn't make much of a difference, but we're just going to go ahead and leave that set to all. And then the next thing I also want to quickly discuss is the cost data. So FDOT currently zeroes out all of their cost data just simply because it takes a lot of effort to constantly update the material library with the latest cost information. So what we typically recommend is hiding the cost data in the quantities report. If you do want cost data to be shown, you can leave that toggled off, but you would just need to make sure that you go into the materials library and edit whatever the cost is. So with that now turned off and our selected bridge and selected units turned to all, we'll leave our accuracy at 3 decimal places and click Submit. So you can see that the program has generated the quantities report in our preview window here. The next step is to export this now to a PDF. So we'll go up to the export portion of the preview window, go to Export to. You'll see you have a variety of options here. And in particular, you have a Word doc, an Excel file. We're going to go ahead and just do the PDF file here. So go ahead and click on the PDF file, and then you'll see that you have a few different options that you can change in this PDF export window. We're just going to leave it all as default and click OK. And then next, we're going to make sure that we're saving our file in the engineering data folder within the structures folder in our work set. So make sure that when you go to save the file, that we're leaving it in this engineering data folder. So go ahead and call this quantities report underscore TR underscore bridge, and go ahead and click save in the engineering data folder. And then it's going to ask you if you want to open this file. We can go ahead and just say yes, and we'll take a look at the information that we have in here. So you can see in here that the quantity report is broken up into different segments. So it'll place the superstructure quantities, so basically the deck components and the beam components, as well as the haunch the superstructure quantities, and then all substructure components will be placed in the substructure quantities. And then lastly, the barriers and bearings and grout pad will all be placed in the miscellaneous quantities there. One thing to point out is that since we used a parametric cell for NBent 3 when we were placing that component, you'll notice that it does not break up the quantity for NBent 3 into cap, cheek walls, piles, etc. It's just gonna say parametric cell basically and tell you the volume of that entire parametric cell all together. So that's one of the current drawbacks to using the parametric cells versus using solids modifications. Likewise, as previously mentioned, when you do use solids modification, it's not going to show up yet because we've not incorporated that into this model yet. But oftentimes the solids modification may not be fully reflected in the quantities, so it's just something that needs to be verified when completing your quantities versus the quantities directly pulled out of the program. Another thing to quickly point out with the quantities report is how the report is broken up. So as I mentioned, it gets broken up into superstructure, substructure, miscellaneous quantities, and also provides things like material name and material type. So like I mentioned before, the accuracy of this quantity report is based on how well you input all of the data into the actual model. So if you want this to be fully reflected accurately, we have to make sure that we're providing the proper material names and feature definitions so that this gets broken up correctly and has the correct pay items and pay units and materials. So that's everything we have regarding the quantity report. So we can go ahead and close out of the PDF and the preview window here. Before I move on to the next step in the exercise, I do want to quickly touch on what I mentioned previously regarding changing any kind of cost data for a material. So if you opted to include the cost data as opposed to hiding it as we did, you can display that cost data with any kind of custom cost that you want to include by accessing the material library in the utilities tab. So if you can just go into the utilities tab, go to libraries and hit the materials library, it'll pop up with the material library window here, and you can see that you can customize the unit cost right in this unit price column right here. So if that is something you want to include, that can just be customized at any point right here. You just click save. So now we're going to move on to the deck elevation report. So to start the process for the deck elevation report, we're going to return to the reports and drawings tab and look into the bridge reporting group again. So there you'll see several different elevation reports that you can generate. We are going to use the deck elevation report, but you also have the ability to generate a pier elevation report, bearing elevation report, the beam elevation and length report, as well as the beam camber report. So those are some of the other useful tools that you can use when you're just trying to grab data out of the model itself. When you're just trying to grab data out of the model. So for the deck, we're going to go ahead and click on deck elevation report. And then it's going to ask us to select the starting limit line for the report. So that's basically going to say, where do you want to start the report at, and then we're going to click on where we want to end the report. So for this specific model, because we did not model the approach slabs to the riding surface, because we did not model the approach slabs to the riding surface, we only modeled them to the concrete portion. We're going to omit those from this report. if we did want to include those, you would just have to make sure you have to make an adjustment to include that asphalt overlay, that additional asphalt overlay thickness in whatever quantity or whatever elevations the report would give back. So what we're going to do is focus on only the bridge. So we'll go ahead and click on the front face of back wall for end bent 1 as our start, and then for our end limit line, we will click on front face of back wall for end bent 3 right here. And next you'll go ahead and left click to accept it, and you'll see this deck elevation window pop up. So within this deck elevation report window, we're going to start tailoring it to the report that we want. I guess the first thing that we'll do is give the report a name. We'll call it TR Bridge Deck Elevations. And then you can see here some of the options that we have when we're going about tailoring this report. So you have the option to change the start and end support lines that we've selected. So if you selected the wrong one at the beginning, you can change that here. Obviously, we chose the two that we want already, so we're going to leave that as is. You also have the option to provide an offset. So that will just start the elevations at an offset from whatever support line you select. So you can go negative or positive offset. We'll leave ours set to 0. Then the report type, you have several different options here on what you actually want to see. We'll go with the consolidated because it'll provide us with a nice concise report. And then transversal lines, those are going to be the lines that run transverse to the alignment. So you have two options here. You can go parallel to the start support, which will just basically offset and have those transverse lines perfectly parallel to the start support. And then you also have the option to go normal to the alignment. That'll just continuously create 90-degree lines off of the alignment. So we're going to go with that option on this curved bridge here. And then the last option we have up top is to select how many points per span we want to create. So that's just going to lay out the amount of lines that we have on our report here. So we're going to change that from 2 to 10. And then the last thing we'll do before generating these lines will be selecting where we want to pull all these elevations at. So the lines we select down here will be where we're pulling all of our elevations at. So for instance, you would go left coping, right coping, alignment, gutter line, etc. So let's go through and start selecting which ones we want. First one will be the alignment. Next, we're going to go to deck 1. That's going to be our main deck component. And then we're going to want to get the left and right coping. So we'll go left deck edge and right deck edge. Next, we're going to want to get our left and right gutter lines. So that'll be indicated by the right edge of sidewalk 1. So that's going to provide our left gutter line. And then the left edge of barrier 2, that's going to provide our right gutter line. And then the very last things that we're going to select are our 2 beam layouts, and that's going to provide elevations along each center line of beam. So we'll select either of those. So next we're going to hit generate. It's going to generate our report. I do want to take a look quickly so you can see what this ends up looking like. Once we generate the lines, you can take a look and see all of our transversal lines here, along with each of the intersections of the lines that we've selected in our references here. So you can see each orange dot represents an intersection of the transversal line and the lines we selected. So that'll give you an idea for what our report's going to end up looking like. So now in our deck report preview window, we're going to go up to export to like we did with our quantity report. So we'll go to export to, and instead of selecting the PDF file, we're going to go ahead and select the XLSX file, create a Excel workbook. Once the export options pop up, we're going to change the sheet name to deck elevations and click OK. Now once the Save As window opens up, we're going to make sure that we're saving our file in the engineering data folder that's found in the structures folder of the workset, similar to the quantity report that we previously have created. So make sure that that's in the correct location. Then we'll change the name to deck elevation report underscore TR bridge and click save. Next, it's going to ask you if you want to open this file. We're going to say yes. And then you'll be able to see our newly created Excel file. So you'll notice now that the title of each table is span 3 and span 4. That's due to the fact that we set support lines for our approach slabs, so it's recognizing the deck as spans 3 and 4 as opposed to 1 and 2. So let's just go ahead and change those titles to read span 1 and span 2. And then just to clean this up, we'll widen the width of this to about 19.5 or 20 or so. And the next step, we're gonna go down to the span 2 deck elevations, and we're just gonna delete the last row here because this is an elevation that's already accounted for in our span 2 elevations. So delete that. Next, we're gonna insert a column before column B just to provide some titles for the names of each of these locations. So we'll just go in, right click on the B column and say insert. And we're just going to go through and name these similar to how it's shown in the actual training guide. So the left deck edge is going to be left coping. Beam 1, we'll say centerline beam 1. Sidewalk 1 is going to be the left gutter line. And then similar to beam 1, we're just going to go down the line with all the beams and say centerline beam 2, centerline beam 3, centerline beam 4, and this one is centerline beam 5. And then for the alignment, we'll call it PGL. And the last two are going to be our right gutter line and our right coping. So we'll just go ahead and copy all those down to span 2. So we're not doubling up our work. And then the last thing we'll do is to edit the names of these titles over here. So we'll just quickly update those to location, front face back wall of end bent 1, centerline bearing. We can leave all these F through P as is. We'll call this one centerline bearing as well. And this last one will be centerline pier. Centerline pier. Centerline pier 2. And we'll just go ahead and copy these down to span 2 as well. but we'll just need to make sure that we update the ends here to properly reflect what's shown. So this should actually be centerline pier 2, and this should be front face of back wall of end bent 3. So that wraps up our work on the deck elevation report. We'll just go ahead, save it, close it, and close the preview report. And we can also save and close this deck elevation report. So the next step in this exercise is to create a horizontal geometry report. This report's a little more unique in that it's civil based and not bridge model based. So that's actually going to be found in a different tab entirely. We're going to navigate up to the Civil tab up here, go into the General Tools group, and that's where you'll find the Geometry Report tool. You can notice there's a drop down next to it that'll give you the option to generate a couple of different reports. Profile report, station offset report are two important ones. Super elevation report is also a good useful tool. But for this exercise, we're going to go ahead with our horizontal geometry report. So next you'll see the horizontal geometry report window pop up over here. You'll have a couple of different options that you can toggle. So we're going to make sure that we're setting the included profiles to all and toggle on the box here. That's just going to include all profiles that are within the alignment that we select to be included in the vertical geometry report. Next, you'll just make sure that you have the start station and end station not toggled on. Then the next step is to actually select our alignment. So we're going to go in and click on the blue alignment here. It should say centerline underscore WB. And then you will right click to complete the selection. So at that point, you'll be asked to select a start station and an end station. So all we really want to do is get the horizontal geometry report in the region of the bridge. So we're just going to go ahead and click our start station to be somewhere before the approach slab over here. And then we'll click an end station to be somewhere beyond the end approach slab. We'll just left click one time to confirm an interval of 0, and then click again to have include event points and put as none. And as we have already mentioned, we are including all profiles, so we will left click one last time to confirm that. So now you'll notice that the horizontal alignment review report has fully populated in our Bentley Civil Report browser. I can quickly scroll through here and show what's included in here. It'll provide you with stations. It'll give you points of interest such as like a point of curvature, the horizontal point of curvature, any kind of changes in horizontal geometry, degree of curvature if you're on an arc. It has a lot of useful information, and you can, assuming that the roadway team providing you with your alignments and profiles has input everything correctly, you should just be able to pull all of your information that you need for any plans work or any calculations directly from your model here. And then one last thing you can take a look at is you can see over on the left side of the window, there are a large variety of different reports and data that can be found in here. One of particular interest is going to end up being our vertical alignment review. So that's basically going to have all of the profile data. So similar to what we just looked at with the horizontal alignment, you can find all of the profile data that's associated with that horizontal alignment you've selected in this vertical alignment review. So also very useful. Again, if roadway has input all their their information correctly. Um, and it should be if you're already modeling off of it, um, then you can pull all of this for any plans or calculation work as well. But again, as always, make sure that as the engineer, you're verifying and coordinating with your roadway team. So that's another good useful tool that can be generated from the program. If you wanted to print this as well, you would just go File, Print. Very, very straightforward, not as involved as the previous reports, but it is a good, powerful tool nonetheless. So I'm going to close out of here, and we are going to get started on the final portion, which is going to be generating our input report. So for our input report, we're going to return to the Reports and Drawings tab. Much like our quantity report and our deck elevation report, this is going to be pulled from our bridge model, not any kind of civil data. So this will reside in the Reports and Data tab up top. Once you get to the Reports and Data tab, you go back to the Bridge Reporting group, and you'll see that there is an Input Report tool there. We're going to go ahead and click on that. And that should open up a preview window. So off to the left, you can see that we have some parameters. That's where we can customize the report a bit. It's very similar to what we were doing with our materials quantities report. So you can select which bridge, active or all. To reiterate, since we only have one model in here, all and active is going to be the same. So we'll just set both of those to all. And then here's where you can kind of customize what you want to include in your report here. For this exercise, we're going to say all, but if you wanted to isolate only a couple of these options, you could do that. So say all you want to take a look at is where the support lines are and make sure that the support lines were input correctly. You can just toggle on support lines as such, and then just click OK. But as I mentioned, we're going to be doing all for this exercise and click OK. And then we can leave our accuracy at the default 3 decimal places. Then you'll go ahead and click submit, and that'll generate the report. So I'll quickly kind of scroll through here. You can see that the report summarizes essentially all of the information that we've input into the model. You can see there's our support lines that were input. It's got all of the data associated with those. You can find all of our deck inputs. So where the start and end support lines are for each segment of deck, as well as what template was used, if we have any vertical offsets, horizontal offsets, materials. All of that information is going to be listed in here. Similarly, we'll have all of our variable constraints that are associated with any of the decks. That will also be summarized in a table here as well. So there's a lot of good, useful information, and this makes this report particularly helpful for anybody who's doing a QC of this model in particular. If you want to just verify a couple of things, or if you need to verify like the entire model, this is a very, very useful report that can be printed out and reviewed. So that is a good piece of information to have and to use in your day-to-day modeling experience. So the next step of this exercise is going to be printing this into a PDF. So we'll go to Export to, like we did on previous reports. We're going to just do our PDF option again. We're going to leave all of our default export options, and we will go ahead and save this as input echo report populate underscore tr underscore bridge. And once again, make sure that you're saving this in the engineering data folder within your structures folder from the work set. Once you click save, it'll ask you if you want to open it. I'm going to go ahead and say yes. And you now have your PDF for your input file. So that'll conclude exercise 7.1. Thank you for watching this section of the training series for F.Connect. Additional training videos and course guides are available on the CAD Office training webpage, which can be found at fdot.gov/CAD.